first speaker, Arnav is an aspiring research physicist and a science communicator. He aims to make scientific reasoning accessible by simplifying complex concepts for wider audiences. Through his YouTube channel, The Astrophysics Sector, and his work tutoring STEM students at Schoolhouse, he promotes rational thinking and scientific literacy. Arnav hopes to inspire curiosity while challenging misconceptions around science. Please welcome Arnav Kathale, presenting Scientists Like to be Proven Wrong, Pseudosciences and Falsifiability.
Good evening, everyone. As an aspiring research physicist, I've often wondered, what is science? And as a follow-up, what is pseudoscience? We'll get to the second question later, so let's focus on the first. What is science? Some of you might consider it a search for the truth, and I guess that's accurate, but only to an extent. See, it also includes fields like mathematics and philosophy, which in a way have very different knowledge systems than any science I know of. So maybe that definition hinges on some connection to the physical world. This is great actually. It even includes fields like theoretical science, which probably just consists of old people with white hair doing math all day, because that math has a connection to the physical world. We might also consider defining science through its purpose, mainly that it aims to develop a model that can both accurately describe and accurately predict all phenomena in the universe. Some of you might also have heard of the scientific method. It's something that prevents a lot of biases and ensures our knowledge is as accurate as can be. So we might want to add it to our definition as well. See, it's difficult to describe exactly what the scientific method is, because it's not a well-defined to-do list. See, different bodies of science are bound to have different methods of exploration. So the scientific method serves as this flexible and adaptable toolkit to ensure accuracy. The pseudoscience is often defined as something that appears like a science but does not follow the key features of the scientific method. These key features include things like controlled variables, peer-reviewed studies, and most relevant to this talk, falsifiable claims and hypotheses. When you talk about falsifiability, there's one name that pops up again and again, that of scientific philosopher Karl Popper, pun intended. He argued that for any claim to be truly scientific, it must be falsifiable. That is, a single genuine counterexample must be sufficient to prove it wrong. Let's think about this through an example. Suppose I think that gravitational acceleration is dependent on mass. It's an intuitive hypothesis that essentially thinks that the heavier an object is, the more it's pulled towards the ground, and so the faster it falls towards it. Of course, anyone who's studied even an ounce of physics will know this is not true. But canonically, I haven't tested it yet. So how do I test this hypothesis? Well, to begin, I'd need to make a claim that follows from my hypothesis and test that claim. So in this case, I'd claim that out of these two objects, the heavier one will reach the ground first when left at the same time. This claim is falsifiable, because if the heavier object reaches the ground second, or even at the same time as the lighter one, my claim has been proven wrong. It has been falsified. So, since my claim followed from my hypothesis logically, my claim being proven wrong would also prove my hypothesis wrong. But how do I come up with an unfalsifiable hypothesis? In this talk, I'll explain a few ways that you could come up with one. The most straightforward method to doing so is through something known as special pleading. To demonstrate, I'll introduce two of my friends. I claim that there is a fire on my hat right here. Hey man, are you okay? Do you need someone to talk to? There's clearly no fire here. Well, the reason for that is actually because it's an invisible fire, so you can't see it. Okay, you can stop playing games right now. Okay, I'll say this again, there's no fire here. I can't feel any heat either. See, the reason for that is because it's an invisible and heatless fire. Okay, well, fire is a chemical reaction, right? So it needs fuel and oxygen to work. If you can point me to what fuel this thing is using and where that fuel is, I'd be happy to comply. Yeah, I can't show you that. Okay, thank God. I thought that you lost your mind there or something. The reason I can't show you that is because, Well, it's an invisible, heatless fire that doesn't need fuel. This is why we're only friend. That, ladies and gentlemen, was special pleading. By introducing auxiliary hypotheses out of thin air just to support my original hypothesis, I have created a claim that cannot be proven false. But it's also useless. As counterintuitive as it may seem, a claim that can explain everything, possible or not, can't actually predict anything. Karl Popper said, irrefutability is not a virtue of a theory, but a vice. Every genuine test of a scientific theory is an attempt to falsify it or refute it. If uh, Now, as a science student, I'm genuinely terrified of all the anti-science rhetoric floating around the internet. To me, it's wild that on social media, scientific information coming from someone who has a PhD is often given the same algorithmic weight as scientific information coming from someone who dropped out of the 10th grade. One of the scariest growing pseudoscientific beliefs is that the Earth is flat. So, is it? No, no, it is not. But is it a pseudoscience? Yes. Of course, the doubt crawls in. But Arnav, the Earth is flat is the most falsifiable hypothesis I've heard in my life. Right? There are hundreds of experiments that we can perform to prove definitively that the Earth could not be flat. We have thousands of hours of space mission footage that show our beautiful blue marble sitting in the vastness of space. But there, my friend, you have fallen for the flat Earth trap. See, the flat Earth belief is tightly bundled with the belief that there is a global conspiracy with all governments and educational institutions trying to brainwash the entire population into believing that the Earth is round. Of course, this new addition means the previous claim is unfalsifiable. There is no piece of evidence that I can bring forth that won't be dismissed as fake propaganda. Okay, if the first method seemed a bit too time-consuming, there's also the second method to choose from, and it's much easier. Just be extremely vague with your claim. Take, for example, my claim that when I increase the temperature of this box, the pressure of the gas inside might change. Of course, logically, there's three possibilities. Either the pressure could increase, decrease, or stay the same. My hypothesis is so vague that it predicts all three of these possibilities. If the pressure increases or decreases, I said it might change. If the pressure stays the same, well, I said it might change, not that it would. Of course, by being so vague, my hypothesis can't be proven false. It's unfalsifiable. One field of study where such claims are often found is that of astrology. Take another example, the claim that I'm bound to meet someone very important on Wednesday. If I graph the importance of everyone I meet on Wednesday, well, you can see this. I don't really know how importance will be quantified, but it should work for now. Instantly, you see that there's no way that I know where the line of very important lies. It could lie at any three of these and an infinite amount of other positions as well. Even if I stay home all day and meet no one at all, you could argue that by staying home all day, meeting myself and myself only, I've met someone very important. Therefore, by being vague and so open to interpretation, the claim cannot be proven false. And so I don't know whether the method that I used to come up with that claim was valid at all. Sean Carlson's famous double-blind test of astrology showed that astrologers' predictions performed often no better than random chance. There's also the major issue of the Barnum effect, where personality claims made by astrologers are often so vague and general that they can apply to almost everyone. So obviously, the people who these claims purport to often report high accuracy ratings, even though these claims are so vague. There are also famous predictions by astrologers like Baba Vanga and Nostradamus, allegedly predicting events like the 9/11 attacks or the Chernobyl disaster. Unfortunately, a closer look at their exact wording shows that they are extremely open to interpretation. In fact, there is still debate going on a lot of their predictions regarding which specific events they refer to, further shedding light on how many different interpretations there are to one prediction. The most glaring issue with predictions like these, however, is that it often follows the confirmation bias, where you only accept information that confirms your beliefs and ignore the rest. In astrology's case, only the predictions that come true are given any attention, while the misses are generally ignored. This is similar to the flat earth behavior of throwing away any contradictory evidence, but without the government conspiracy angle. You could even consider the confirmation bias the third and often simplest method to create an unfalsifiable hypothesis. See, in your perspective, by ignoring all the evidence that goes against your beliefs, you've technically created an unfalsifiable hypothesis. So, how does one not fall into pseudoscience? It may seem like a complicated answer is in order, but it genuinely isn't. See, the main trait that differentiates a scientist from a pseudoscientist is their reaction to evidence that contradicts their hypothesis. A scientist will create a falsifiable hypothesis, do their best to falsify it, because every time they are proven wrong just adds to our knowledge of the universe. A pseudoscientist, on the other hand, will often try their best to remain correct. They'll perform special pleading, ignore the evidence outright, or just start off with an unfalsifiable hypothesis from the get-go. See, real science demands humility. You may be wrong, and that's okay. We are bound to make mistakes while decoding the universe. Thank you.